And good morning. Sorry. Good Sunday morning, everybody. I don't care where you are in the world, what time zone you're in. At the moment, it is now 10:01 a.m. for you, for everybody. Okay, so we've all got to be quiet because Michael is feeling rather poorly this morning. Nobody type loudly. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Good morning to Alistair. Alistair is here again. So cool to see you in the chat, Alistair. Austin, Cable Tie, David, Dodgy is here. Imi, of course. James O'Gorman. James, is your... I can't really tell from your thumbnail. Is that you or is that Adam Savage? No, I think it's you. It's a very, very small thumbnail. I think it's a NASA shirt, not a Savage Industries shirt. Also, good morning to Jax Tech, Keith H. Good morning, Keith. Luminator, Mitchell, Crispian, Pancake Legend is here as well. Pancake, your sore spot is here, safe and sound. I took it to the Prusa user group meetup and demoed it to Joseph, and he quite liked it. But anyway, let's not get into that right now. Scott Miller, some call it fun. Stephen W, The Lane, Tradie Trev, Sion, Wagon Loads, David, as in David House. We have several Davids in the chat. John Whips, Michael Wise, Sharky, David, as in David Kaiser, one of the others, Jeff Miller, David T, Tassie Bob, Gavin Jackson, and Andrew Gordon. I think that's everybody. Did I say hi to Mitchell earlier? I don't know. I don't know. But anyway, good morning to everybody. Good Sunday morning. So, over the last few weeks, I've ended up with a few little things, little topics accumulating that I think could be interesting to talk about. It looks like you're all out of focus. And it's not you, it's me. Because these glasses are dirty. Yes, I need to chuck these in the ultrasonic cleaner. Get them properly clean. What I actually need is new glasses because my prescription has drifted.
Said cannot run out of time. There is infinite time. You are finite. Zathras is finite. This is wrong tool. No, no, not good. No, never use that.
Yeah, Peter, you are right. You are right. Well, maybe there is infinite time. There is infinite time. There is effectively infinite time compared to my lifetime. But yes, I am finite. My lifetime is very finite. But bigger than that, there is plenty of time. I just don't get to experience much of it. Just this little blip. The little blip in the stream. What's going on? Are we getting philosophical? I don't know. Okay, so as I was starting to say, I have accumulated a whole lot of little snippets of topics and things that could be fun to talk about. And that includes millimeter wave radar, because I have a couple of millimeter wave radar units that were dropped off at the last barbecue and for me to do some testing with. There is the dummy load thing. Anyway, there are a whole lot of other little snippet things as well. Before I get into that though, the major thing that I was thinking of talking about today, kind of changed my mind last minute, was I wanted to talk about assistive tech projects. The reason being that today would be the 46th birthday for my dear friends Nick and Chris Fryer, who both passed away a couple of years ago. So Chris passed away January last year. So a year and 4-ish months ago, 3 months ago. And Nick passed away a few years prior to that. And I spent, I think it was about 5 years working with the two of them on assistive tech projects. Things like wheelchair modifications, linking into the control system of the wheelchair. I've talked about this sort of thing before. I've done conference talks about it. Chris and I did a joint talk at LCA a few years ago in Brisbane. And was it Brisbane or Gold Coast? Gold Coast. And so I have talked about it quite a lot over the years, but I've always talked about it in fairly general terms. And I want to talk about some of these projects in much more specific terms. Crispian asked, they had the same birthday? Yes. They were clones. That's what they used to say. I think it was Nick who used to say that he kept Chris around for spare parts. Yeah, the world's greatest clones was what they called each other. They called themselves. Yeah, they're identical twins, Crispian. Just to clarify what's going on there. Yeah, so they are identical twins with, therefore, the same genetic issues, including Duchenne muscular dystrophy, which is what effectively controlled the course of their lives and resulted in them having a much reduced lifespan. Yeah, Imi says, happy birthday to Nick and Chris from Earth. Yes. Christchurch. Oh, Mike asked Christchurch. No, I did so this is talking about the LCA talk. I did a talk at Christchurch about the projects that I was just starting. So that was reasonably early on when I was working with Nick primarily. I did a talk about the projects that I had worked on with Nick, and that talk was not long after Nick had passed away. And then a few years later, Chris wanted to attend LCA as well. So this was after I'd been working with Chris on a whole lot of assistive tech projects. And we took a road trip up north to Queensland and did a joint presentation at LCA. So today is a significant day. And this afternoon I'm going to go over and visit their mum and their stepdad, Peter, their mum, Jenny. Yeah, so many LCA talks over so many years. Yeah. And so many mini-confs. So, I had been thinking about talking about projects specifically, going into the tech of how things work. But I think I'm going to wait on that. What I would like to do is go through some of the projects that we put together. The projects that we built were driven by the specific needs of Nick and Chris and the things that they wanted to do, what their goals were. And even though we published all of our designs, everything that we worked on is on GitHub under open licenses, a lot of it is not very polished. It's in the state of, we built this thing and we got it working, and they could use it or we could test it, but it was not really in a state where it's documented enough for other people to be able to take that and run with it and use it for their own purposes, unless they had quite a high degree of technical capability. So one thing that I would like to do is go back and revisit the projects that I worked on with Nick and Chris, and this is the wrong word, but I'll say complete them in the context of completed to the point where all of the files related to it, all of the designs are published, they're in a reasonable form, other people can come along and use them, so that what we did was not just of benefit to them, but can be a benefit to other people as well. So I think that is probably the best way that I can honour their memory and the time that we spent together. Scott said, are there any projects anywhere on GitHub that are fully polished? I've seen some pretty good ones. I've seen some really, really interesting ones. Yes. I saw one.
Said continue them to general ready status.
Yeah, general ready status. That's a good way of putting it. Thanks, Peter. Just recently I came across a project on GitHub. I can't remember what it was. I wish I had taken note of it. I came across a project that was incredibly well polished. It was someone's personal project, something that they had built, and they had gone to the trouble of documenting everything. It had really nice diagrams. It had all the setup procedure and assembly notes, and yeah, it was a really, really impressive piece of work. But I can't remember what it was. It was for some hardware thing. A lot of software is very well documented on GitHub, and somehow that doesn't seem as impressive, because most of the time it is source code plus build environment and some configuration instructions and things like that. But for hardware projects to be really well documented is very difficult. In fact, well, this is chasing a squirrel to some extent. But this, hang on, what happened to my browser window? This right here is something that I just came across as a way, there are many of these sorts of projects as well, documentation projects, but this is something that I just came across. I don't know anything about it. I just thought it looked interesting, and I've got this open as one of my many tabs to check back on later to see how it was done. I was reminded of it because it was actually visible on my screen at the time that I was just talking about this. It was down on the other monitor. Okay. Oh, Peter, you are here live. Unbelievable. Good morning, Peter. Yes. Oh, okay. So Imi just talking about that reminded me. So Imi said a very special project with many A, D, and HDs involved. Yeah. So one of the other things, where did it go? I think it's sitting right here somewhere. Oh no, I probably put it in the vehicle data logging box. So many of you will already know about the little ELM327 based OBD interface devices that you can plug into your car and get diagnostic information from it. And IMI has one of those with Wi-Fi built in, which I've never seen. Well, I haven't pulled one apart before. I've seen them, that sort of thing before. And supposedly it doesn't work. So one of the things I'm going to do is open it up, and we shall investigate how that board works. But I don't think that's for today, because what I want to do today is have a look at the dummy load that I got. So this is the one that John Boxall talked about. Oh, Mike has joined the chat as well. So has Tabraze. Mr. Fixit 1952, Peter Oakley, of course, I just said hello to. Johnny is here now as well. Andrew, there's an Andrew Gordon, Tassie Bob. Yeah, a couple of people have joined. Where is it? Where? This thing. Oh, it's still in its box. We'll get to this. Oh, before I get to that, I'm going to grab out the dummy load that I have been using. Show you what that is. And explain a little about what a dummy load is. Oh. All right. So, I've got to show you this. So, this weird looking science project thing is something that just uses power for no particular purpose. It takes power and just disperses it into the air as heat at a controlled rate. This is one of those things that can be a little bit weird to explain. So let's see. Oh, and this we will get to later. Just get those out of the way. Yep, I'll unplug that. So this battery pack is what we are going to be using for testing the dummy load, I think. Anyway, this. How am I going to do it? I want to demonstrate this. Alright, so first thing is, I need to power it. And then I will explain what the hell is going on here. Alright, so I've got power in the back, we've got a display on the front. It's currently set to, it's showing 0 volts, 0.01 amps. I've got an input here, which is where it's going to be drawing power from. Oh, actually, I can probably use this. Yeah, I can. That's alright. Okay, so I'll put the dummy load on the right. I'll put this here. I don't know what this is set to, so hopefully this won't go bang when I plug this in. Nothing. Get nothing. Nothing. Oh well. Oh, that's because that's on the charge side, I think. Okay, I'm going to need to do some connection stuff here. What do I need? And in fact, what am I even trying to do? What I'm trying to do is just show you what this weird bag of tricks does. So I need to plug in, I think the easiest way to do this is going to be to plug in a power supply. So I'm going to grab, in fact what I can do is go, woo, is that going to work? No. My phone has shut down. Wake up, phone. Wake up. Wake up. Unlock. Oh, hang on. I hope you can still hear me. Is Droid Cam still running? Is it? Yes, it is. Hooray! Okay, so we now have an overall view. So this is what I'm going to do is grab some, I think, alligator leads. Everything is falling off. Alligator leads is going to be the simplest solution here.
I'm scared. It's dark.
Yeah, it went dark briefly.
Mutual R said we can hear you, but you smoked the candle.
Yeah, that's my... in fact, is that running? Maybe the reason it went out. That should be okay. Should be charging. I'm using my old Android phone as a mobile camera. Now, we'll get... That's all right, that can stay there. We'll move that out of the way. Let's make all of this less confusing. Unplug that. Plug that into power supply 2. And in a moment I'm going to cut back to the overhead camera so you can get a better view. So what have we got? V in plus at the top, V in minus at the bottom. So I'll go V in plus, V in minus. Okay, so what we've got here, if you look up here, I've got this little lab power supply. It's currently set to 12 volts, 4 amps.
Said, hey folks, please don't forget to dislike and unsubscribe.
Yeah, that's right. Hit that dislike button. Now, what this device is going to do is when I turn on the output of this power supply, this is going to start using power and just dumping it out as heat, and it turns the fans on to cool. So down underneath here there are some MOSFETs or something that it uses. So I'm going to turn on the power supply, and you can see that it is now showing, whoop, you can't really see unless I switch to that. Okay, so you can see that we're getting 12.2 volts coming in here, 0.01 amps, and it's showing how much power is being used, which is approximately nothing. But then if I, which one is it? Coarse fine. So if I turn the coarse knob up, you'll see that it will start consuming power. And it has just turned on the fan, and we're now pulling 0.9 of an amp. If I turn it up just down a little bit. So we're now pulling 1 amp. There we go, I almost had it. And then I can switch to the fine tune knob to make the fine adjustments. So we're pulling an amp, and the voltage has dropped a little bit to 10.8, 11 volts. The power supply is still set on 12 volts, but there's voltage drop in these dodgy alligator leads and things. So we're pulling power from whatever power source we have connected to this. And it's got all of these different inputs. It's got USB Type-C, and there's micro USB, there's mini USB, there's just like a DC jack. These are the alligator clips. There's another USB connector down here, one of the big USB-A type. So the idea is that whatever you want to test, like a power supply or a battery pack or whatever, you can arbitrarily pull power from it, and you can configure how much power you want it to pull. So I'm going to turn this up to 2.5 amps, something like that. So we're now pulling 2.5 amps out of the lab power supply. Now this is a bit of a silly example because I am just running it off a lab power supply. There's really no point doing this unless you are testing the power supply, just to make sure that it really can do its thing. So one way of using that, one example would be, if I go to the lab power supply and I go, I'm going to turn down the current on the load. So the load is still drawing power, but not very much. And I'm going to set the current limit to 1.5 amps. Okay, so current limit on the power supply is now 1.5 amps. And now if I come back to the load and I turn it up, it's going to go up to an amp, 1.2 amps, 1.3 amps, 145, 152, 1.5. See, it stopped there. It can't get more than 1.5 amps out of the power supply because the power supply's current limit has kicked in and it's now in constant current mode and the voltage has dropped. And then if I turn down the load below that, all of a sudden the voltage goes up and the current makes sense again. So this device, it's one of those things that when you first hear about them you think, what the hell is the point of that? It just uses power. But it can be very, very useful. It's a great piece of test equipment or diagnostic equipment when you are dealing with things like motor drivers, where you might want to test a board that has drivers on it that control a DC motor, and you want to be able to simulate that motor in different conditions. So the motor running in steady state, or maybe the motor stalling, where
Even Lola said I don't remember how to override the...
and you want to just make sure that the motor driver is working properly and that it's able to deliver the current that is required, etc. So testing motor drivers is one good use of this. So that you put this in place of the motor and then you dial up the load that you want and the motor driver will try to deliver it. And another good use is for things like battery packs. You can connect this to the output of a battery pack.
Pro tip, if you have more than one Google account, just like this video on all of them.
Thanks, Peter. Yeah, if you've got a battery pack, you can discharge the batteries through the dummy load to do things like test the amount of power that the battery pack can provide. And so this So this dummy load that you can see right here, this is the one that I've been using for years and years. I got it on AliExpress at some point because I was needing to test something. I can't remember how much this was, but I don't think it was very much. It was probably in the order of, I'm just making up numbers here, but at a guess, it was probably like 50 bucks or something. It's one of those things that if you need it, like if you need a way to apply a load to some kind of a power source, this is a really cool, quick and easy way of doing it, because you can just dial up the load that you want. Turn the knob and you can see exactly what's happening, like how much power is coming out. So this has been extremely useful for me a couple of times, but as you can see, it looks like a science experiment. It's partly deliberately. It's got these funky fans in it with LEDs, and yeah, it looks actually kind of cool. I should stick it up on the shelf and just leave it turned on all the time, because it looks kind of cool. But it is a bit limited. It's reasonably low power. It can't.
R said IT has no RGB. Throw it in the bin.
Yeah, no RGB. That needs to be fixed. It's
Imogen Ann said it has more porpoise than the sea rolling on the floor laughing.
So it's okay. There are some limitations. Firstly, the way you set the load is by turning these knobs. You can't do it in advance. You have to do it by turning it on, loading it up, and then turning the knob. So you can't preset an amount of load that you want to apply. You also can't specify it explicitly. Like there's no keypad here where I could dial up 1.5 amps set and then say how much current I want this to be pulling out of whatever I've connected it to. There's no remote control of it. It's only using these knobs. There's no data logging, so I can't see historically what has happened. And it's fairly limited in terms of how much power you can pull out of this. I can't remember what the current rating is on this, but I know that I've hit it in the past. All the documentation on the back is in Chinese. 36 volts. Yeah, okay, so 36 volts max. And I don't know, but I don't know what power. Quick charge trigger in. Fan jack course. Yeah. So, cool thing, very cool thing. And it's certainly been very helpful to me. But when was it? About 2 weeks ago? A week and a half ago, John Boxall posted that Element 14 had a special on dummy loads. I'm going to turn this off now because I'm going to bring up the other thing and let's see what it was that has come in this box. Oh yeah. So this is the dummy load that has been sitting in this box unopened for all this time. The fact that it says Element 14 security seal means that this may be a repack, possibly, because the original tape was under this. Nothing exciting. And yes, I'm aware that this is kind of an unboxing video, but it's not. Ooh, these are nice chunky leads. Another power lead. Get these out of the way. What's that? Cereal? Maybe? What else do I have down here? Oh, there are more cables that are underneath, but I can't see them at the moment. Alright, let's move around a little bit. Get this out on the bench. What else is there? USB cable, another power cable. It's come with 3 IEC leads. This is not ASMR, that's for sure. How do I get this bag open? I'm not qualified to open a plastic bag, so I definitely am not qualified to use this device. Get off. Alright. So it's a little bit different. Compare that to that. It is just slightly different.
Mitchell R said it sounds like ASMR lol.
Yeah, so this is this is a it's actually very heavy. It's probably not, it looks like just a little box on camera like that, but this is actually really quite solid. So that compared to this little science experiment. Let's see what this thing does. Oh, okay. I gotta peel off this plastic. This is the best bit of the whole thing. Ah, so good. All right. Oh, huge. These are I thought these were knobs. You see these things here? I thought these were like adjustment knobs or something, but no. These are massive screw terminals for high current connections. So it comes with these power leads for connecting up.
Said DEFINATELYASMR with that peel.
Okay. These power cables are huge. What are they?
Imogen Ann said it looks like one of those set-top boxes for your TV.
It does a bit, looks a bit like a set-top box. So 10 AWG cables that can go onto these screw terminals to go to whatever it is that you're wanting to measure. And I'm pretty sure I'm going to end up making XT60 leads for this. Oh, what have we got on the back? Serial USB line. What does line mean? It's an RJ45 socket, but is that actually Ethernet? I have no idea. Sense, trigger in, and looking through inside, it's got like it's got a very big heatsink inside with all of the fins directly in line with this back vent so that air can blow straight through across the heatsink. So that's how it's going to be dissipating all its power. And from what I understand, there is some way of controlling or programming this, maybe via serial or over the network or something. And part of the reason that I wanted this...
R said tear down time.
Yeah, pull it open and have a look inside. Do a Dave Jones on it. Power. First thing is I want to turn it on. Which is... Oh, there's a UK power cord. Australian power cord. Whatever that one is. Don't care. One with two prongs on it. Is that British? Just with two round pins. Why is it that every country except mine's power cord looks ridiculous? Huh. Could be habituation from childhood. Maybe that's the answer. Alright. Power. Got to get some power. There is some just over here. I know, everybody outside of Australia, New Zealand and China looks at our power connectors and think they are ridiculous. Alright.
Scott Miller said John can't do a Dave Jones. He doesn't sound whiny enough. Ooh. I just started fiddling with it and it, is that a button? No. Okay, so set. I don't know what's going on here. Looks like it's got a whole lot of memories. I'm going to have to actually read the manual for this. So I've got trigger, short, save, run, beep. I can turn beep on and off maybe. Oh no, that's using it as a numeric keypad for entering. So I've got 111 amps set there, which is not exactly going to work. Where's enter? Enter? Okay, so constant current, 0.1 amp. Can I turn that up? Can I... This is
Oh yeah, so I can step through, make that 0, step through, make that 1. Okay, so I can change the 1 amp digit there. And then how do I set it? If I press CC again, no. Where is max set, list trigger, dynamic? Where is save? Oh, and there's on off as well, which means we can, unlike this one, which is just always drawing.
NZ and US power pods are cap lol. EU and old ZA is a pitter.
Max set, dynamic, on enter. Oh, there's enter. Okay, so if I go to that one, increase that to 1 amp, step through. Why can't they have left and right buttons?
More importantly, does it do 1.21 gigawatts?
I don't think it'll do that many gigawatts. And then if I press enter, okay, so I've now set it to a 1 amp load, I think. So it's in constant current mode. So we can do constant current, constant voltage. What is CW? Oh, constant power, constant watts is my guess. CR, maybe that's constant resistance. Don't know. Save, beep, blah, blah, blah. Let's see if I do shift beep. Has that turned beeping off? Yes, it has. Is there an escape? Nope. Oh, okay, if I just hit constant current, then it goes back to whatever the previous value was. So, oh, and there's an escape explicitly up there. Nice. All right, short, blah, 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 comms. Okay, who knows what's going on? Certainly not me. But what we can do is, as a... I should have got the camera in much closer for that. Sorry, I only just realized how far away it is that your view is. Let's bring these cables over so that I can then connect up the output from the lab power supply. Yes, I probably should have taken them under, but who cares? I'm just figuring this out. All right. So lab power supply is off. Connect
Mitchell R said
positive to positive,
smoke from.
negative to negative. Yeah, I'm going to see if I can get a better view.
Smoke, smoke,
Smoke.
smoke, smoke.
Yeah, get the chant going. Here we go. Can I zoom? Oh, kinda. Okay. That sort of works. Almost. In that field of view, you can see, yeah, you can see the lab power supply here. You can see the front of the dummy load. The output from the lab power supply is coming down and connected to the input of the dummy load. And I've got the load set to 1 amp. I've got the power supply set to 1.5 amps. So I'm just going to turn this on. I don't think anything is going to happen initially because I haven't turned on the load. Oh, that's interesting. It did. Something strange was happening. All right, let's try turning that on. That's interesting. There's some kind of an interaction happening between the current limiting on the lab supply and the load. The current limiting on here is just frequent. It's just kicking in and out, in and out, in and out. That is quite odd. Okay, so I'm going to try decreasing the load on this. It could also just be that I've got it in the wrong mode on. Yep. So, and I think the beeps are coming. Where are the beeps coming from? Maybe from this. I actually couldn't tell. I know you can't tell because you can't pick the direction. Yeah, the beeps are coming from this, not from the lab power supply. So what do we need to do? All right. I can try decreasing the current, or maybe do I need to set a voltage? But it's in constant current mode, which means I shouldn't set a voltage. It should just get whatever voltage is being supplied to it. I don't know. All right, So I'm going to decrease the load. So I'm going to go to 0.9, 0.8, 0.7, 6. I'm going to set it to 400 milliamps. Oh, okay. How do I set that? I've got to press enter. All right, so that, and then where's enter? Where's enter? There it is. Okay, so now I've got that set to 0.5. Turn on the power supply again. Okay, what am I missing? How does this thing work? It's obviously not as simple as the other one. Let's just try setting it to constant voltage mode. Constant voltage.
Mitchell R said try press the knob in for enter.
Yeah, it's not a... The knob is not a button, unfortunately. Alright, I'm going to set that to 11 volts and enter. Oh, 11.1, but who cares?
Mitchell R. said there is a manual right next to you. Maybe open it long.
This thing? This thing? Yeah, maybe I should. Let's see if we can figure this thing out. Why does it just beep as soon as I apply power to it? Oh, I know why. I know exactly why. Hang on, I'm going to show you something funny. And it's because I plugged it together like this. Hang on, I'm going to switch to overhead camera. I plugged it together like this, right? You see what's going on there? Positive to positive. But no, when you turn the lead over, that's actually the negative lead, because this wire is yeah, it has a black line on it. I need to get rid of these alligator leads. So it was complaining about reverse voltage.
Mitchell R. said told you opening the manual will help lol.
Yeah, thanks Mitchell. Opening the manual did help. Okay, so now this, you can see I've got
Scott
negative
Lewis said
input,
rolling on the floor laughing.
red there, but if I turn it over, it's black and black. Yeah. It was protecting itself against reverse reverse current, reverse voltage. All right, so let's try again. I'm going to, I put it back into constant current mode, put it into 0.5 amps. See, this is why you shouldn't trust me to do anything. And I'm going to turn this on. We don't have beeping. Yay. And then I'm going to turn on the load. So at the moment, I've turned on the power supply. It's trying to deliver 12.3 volts, just because that's what it was set to, 1.5 amp limit. On here, I have got it reading, so we're reading the input is 12.295 volts, which is good. At the moment, we don't have any current being consumed because the load is turned off. So if I turn on the load, there we go. We can see now that there is...
Scott said it was the anti-John beep.
Yeah, the anti-John beep. Well, the good thing is at least now we know that it's immune to reverse voltage. It has a freak out session and tells us about it, but now I know if I hear that crazy beeping in future, I've probably crossed the streams. Yeah, so we can see that we're currently consuming 0.499 of an amp. We've got it set to 0.5 of an amp. We're reading 11.621 volts on the output. The power supply is trying to deliver 12.3 volts, but there is some voltage drop in those alligator leads. And you can see the watt value here. So 5.8 watts is what is currently being delivered by the power supply and consumed by the load. Ooh, it says, do not remove covers, refer servicing to qualified personnel. I have just proven that I am dramatically unqualified, but hey, I don't care. I bought this, I own it, I can do what I like with it. Yeah, so now if I wanted to increase the load on this, what it looks like is that if I don't go into like entry mode and I just start turning the knob, it'll turn whatever is the most significant digit that's currently set. So if I turn it to the right one click, there we go, it's gone up to 0.6, but it's also gone into set mode, which is interesting. Oh, we're pulling 0.6 now. Turn again, go to 0.7, we're now pulling 0.7 of an amp, 0.8, and then enter to get out of set mode. Well, now that I know not to plug it in backwards, yeah, this makes sense. I can set a current, it's telling me what's being delivered. This is all good. Now, part of the objective with this, one of the reasons that I was interested in this, is that it has that serial port on the back, which means we should be able to get some data out of this. I have no idea how, or whether it's in some stupid format, or what's going on, but for the price. So this, for the record, this cost, I think it was $201 with free shipping. So it was like, it was just barely over the $200 mark. It was some strange amount, like $201.38 or whatever. It had some discount applied to it because they were originally, I don't know what the price on these was originally. I think it might have been $600 and something, and there were like a dozen of them or something that were being cleared out at Element 14. Sequential. Hopefully it's not some stupid thing where you have to use their proprietary software that only runs on Windows 7 on a full moon, but it is something that actually just sends out useful data out the serial port. Okay, it'd be nice if it was in a basic sort of format that can be read. Enter Vion. Yeah, this is all about the front panel, like how to use control through here. It doesn't have anything about serial interface that I can see. Although I should probably look at the index. Battery test, sequential operator, blah blah blah. Rear panel, remote board rate setting. Here we go. Board rate setting 26, communication, page 26. What is it going to say on page 26? Probably use our software. Communication with PC, please refer to the communication protocol. When the keyboard is not locked, press escape at any time to return to the steady state mode. From one mode, switch to another mode, press escape, blah, blah, blah. Okay, please refer to the communications protocol. Where? Come on. Where is the communications protocol? Where? Okay. Maybe that's not something for today. Or maybe it's something that I can do a bit of quick Googling on and see what we can find. Let's have a look. 10 MAR programmable load. What model is this? It is a 7213-200, I think. Yeah, 7213-200. Oh, okay. There are some other versions here listed at Element 14. So these ones are currently like just under $400. I don't know which one I got. I don't know. How many watts is this rated to? 150 watts. Okay, so up to 120 volts and up to 30 amps with, not at the same time obviously, because that would be a very, very large number of wattages. And so yes, anyway, what am I doing? 150, it is the 13200, 72 13200. I don't know what the difference between these two is, but let's have a look. Datasheet. Does this tell us anything useful at all? Nope, it's just sales information. But what I can do is do this and this serial port. New Windows USB driver. Oh, okay. Electronic DC load. No, go away. Windows USB. Don't know. Don't know. Serial protocol. Oh look, we're on Reddit. No. Oh, okay. Let's go and have a look at Dave's forum. Hang on, what happened then? Did that just download something? I think it did. What did it download? Manual is here. Tenma 13200. Text controller must be restarted before any changes. ID string. Okay. I wonder where
Mitchell
that came
said,
from.
Did you read it?
Did I what? Did you read it? Don't know. Okay. So it looks like this is a configuration file of some sort for a device that interfaces with it, or some kind of like a driver. Metadef. So that came from here, but where is it referenced? Oh look, here's a repair and tear down of one of these. So this way at least we can see what's inside it.
Reddit tilde read. It tilde Reddit.
Ah, Reddit. Yes. Read it. I don't know. I don't know if it's worth exploring this. This is one of these things where I'm just going to end up sitting Googling and reading random pages. I could be doing this for the next hour, trying to find some useful source of information about this load. And that is not...
Mitchell said sorry, thought it was punny.
It is punny. But that's not very exciting. So maybe we should do something else. Now that I've shown you the load, at least you've seen what it is. Anyway, okay, so the part of the point, what I was starting to get at here, and the reason that I am looking for the programming interface for this, is that I'm thinking of how to link this to the test jig system that I'm building. Because what I want to be able to do is incorporate some kind of a dummy load into the test jig for testing things like motor driver outputs. And what I could do is set it up so that when the test is run, it communicates with the load, puts it into the correct mode, sets what limit that it wants, and then turns it on and reads back what's happening. So you can tell if you have, I mean, I keep talking about this because this is the example, this is the thing that I actually need this for. Motor drivers, so that if I have a motor driver on a board, I can run the output of the motor driver into the dummy load, and I can apply load to that motor driver and measure that it really is working. I can see how much power it is putting out. I can check that the voltage hasn't dropped, which then shows there is no short circuit, etc. Oh, Mitchell. While I've been blathering on, Mitchell has been on the job. The chat is a little bit behind. Hang on, I'm going to copy a URL out of chat. Hang on, why was Mitchell denied? Mitchell, you are being disrespected by your own system. Oh no, that's not... What? What the hell was that? I just did a copy out of... What? I don't know even where that came from. I just tried to copy out a URL. Hang on. What is going on here? This is some kind of weird... I don't even understand what just happened. Where did those words come from? Anyway, I'm going to close that tab and pretend I never saw it. So what I was trying to search, what I was trying to put in was that. I copied that. All right, I'm going to hit enter. What the... When I did a copy out of the... yeah, it's a copy of the chat, yes. I tried to copy just like the one string out of the chat, and I think it selected a large chunk of the chat, and then when I pasted in it, yeah, whatever happened. Okay, Tenma DC power supply controllers. So this is for a power supply, not a load, but it may well be a clue because they probably use the same sort of protocol. Also, even if not described, should support Korodka models and Velleman, which are rebranding. All right. Original code. Pip install Tenma serial. Install requirements. Okay, provided USB cable. It has a regular RS232 cable. It comes with this one. Set the current Tenma control. Blah blah blah. Yeah, well, this is not for the exact same device, but Mitchell, this could be very useful because hopefully they use a similar sort of protocol. Examples, Tenma, test, stocks. Let's have a look at what it is doing. Tenma control.py. How is this thing working? Parser, add argument, blah, blah, blah. Yep, okay, that's all the command line stuff. I want to see where it's doing its protocol. T recall. T save conf. Printing, loading from memory. Okay, so the interesting stuff is possibly in Tenma DC lib. This is probably where it specifies what the actual thing is. So it's manufacturer manual. Alan, welcome.
System notification. 1 hour remaining.
The throwback to that link. Mitchell said just click the link. Yeah, I was doing it. Does it do it as a link in here? No. I was doing it from Mitchell's chat interface instead of from the actual YouTube chat. I could have just clicked on the link in the YouTube chat. What am I doing? If to blah 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 plus serial EOL, yeah, blah. Find that. Tenma serial handler. Okay, so this is where we're getting into the more interesting stuff. So setting up a serial port, 9600 bits a second, and yeah, opening the port. It's the protocol stuff that I want to see. Oh yeah, Mitchell, links are unclickable, but that was not a feature request. You don't need to make them clickable. So read output self, 10 my base. Match string, okay, 72 base, set some defaults, whatever that means. Set some default, oh, okay. 72 base, so 72 is the series of the model number of the lab power supplies that this is related to. So what it does is set a base class with some values, and then it can be extended by subclassing to create drivers for other types of devices. So what have we got? It's just got a whole lot of stubs. Not doing anything much. Close, check channel. Yeah, maybe it's in the device specific stuff where all the interesting thing is. Right, if blah self max milliamp. Check self. It doesn't help that I don't really do Python stuff very much at all, so the syntax here is not very it's not second nature to me. I've got I wonder what the send command method does. Self.send command. Where is that defined? In this file, def, there we go. Got to say, the code browsing in GitHub it's really good. It's almost like being in an IDE. You can select something and then go to the definition of it. You can see all the references to that that method. Okay, so if debug, then do that. Command equals command plus self serial end of line, and then serial write command code, command encode ASCII, give it time. Okay, so we're taking the command, whatever that happens to be, encoding it as ASCII, sending it to the serial port at 9600 bits a second. But what does that command look like? Where is command defined? So command is command plus end of line, command dot strip. Okay, so command comes in from here. It's being passed in to send command. So let's find a reference. IDN status. Oh, okay. Command check. So it could be as simple as status question mark end of line. And if we sent that out the serial port, we might get a useful response. Channel 1 mode, channel 2 mode, status hex 01, hex 02, tracking beep log out. Status bytes is read bytes. Independent, tracking series, tracking parallel. Yeah, this is all power supply related, like dual channel power supply control. Whether you want the two outputs of the power supply to be independent, tracking values in series, tracking values in parallel, etc. Channel 1 mode. Okay. Is set blah format blah. IDN. This all looks like yeah, as Stephen W says, classic 9600 8M1. Yeah, it's basic lowest common denominator stuff. Ooh, okay. So here's another link from Mitchell. I'll see if I can put this in without chaos. Here we go. Tenma API. You can use Tenma class you deem necessary. Okay, referencing your model. From either USB or serial. Yep. All right. Check channel. Yeah. Now, at this point, we are working on the assumption that this dummy load uses the same programming interface as their power supplies, which you would think is a safe assumption, but it may not be. Because a lot of this stuff is like it's rebranded, or they use a control chip for the power supply that has a particular protocol built into it. It's not necessarily their protocol. It'll be whatever is in the controller. And then their dummy load might have a controller from a different supplier.
Mitchell R. said unknown if anything works OFC, but I think best thing gone be plug serial in and see.
Yeah, that's exactly right. So this gives us, oh, excuse me. What this gives us is some clues to what it is likely to be like. And if we can experiment, like send the, wherever it was, the status command, not the is set, but the status, wherever it was back up here. Like if we just connect on serial and we send status question mark and see what happens, at least it'll tell us if we're on the right track. Now, how can I do that? What I need is USB to serial. USB to serial. Do I have something handy that'll work on the Mac? Maybe? Maybe. I have plenty of USB to serial, but the issue is USB to serial that has the correct connection on it. I just want one of these DB9 connectors because I don't want to be messing around with jumper wires because I'm lazy, but we all know that already. Just checking if I've got an old style USB to serial adapter in there.
Even W says it had a USB port you said earlier.
I don't think so. Let's see. Hang on, I'm going to turn off this and... Oh, no, it does have a USB port. It does. It does. Yes. Thank you very much. So maybe this cable will do it. With luck, this will be as simple as plugging in the USB, opening a serial port, and typing commands to it.
Mitchell R. said, now the question is driver's law.
Yeah, what is it going to appear as on the computer? Is it going to be some stupid thing like a, I don't know, whatever the worst, cheapest, dodgiest USB connection is? Alright, so I've got the cable here. Let's open CoolTerm. Yeah, Stephen says if they've used a standard CH340 or something, it should just work. Yeah, the CH340s can be a pain though. Alright, now I'm going to bring this up here. So this is CoolTerm, and you can see that at the moment I've only got Bluetooth, WLAN debug and custom. That's it, and TCP. So we've got no other ports connected. I'm going to, if I can get this cable to reach my computer. Oh, okay. Plugged in. Plugged in. Now rescan serial ports. What do we have? USB modem. Here we go. 9600 bits a second. Terminal, I want it in line mode. I don't know if we need carriage return or line feed. Might as well send both and we'll see what happens. Okay, and connect. Alright, so I'm going to send it status question mark. And I got nothing. Damn. Well. Alright, I'm just going to send question mark. How about help? Nope. Disconnect and options. Just want to make sure. What have we got? Serial port. 9600 8N1. That's what we want. We've got the port selected. They were using /n as the line end. Try just a question mark. Yeah. So /n means new line. which is LF, I think. I'll try that. Connect. And question mark, nope. Status question mark, nope. Just status, nope. Help, nope. Help, nope. Well, that's sad. I wonder if I have to do something like turn on serial communications. Let's have a quick look. Communicate. Please refer to the communications protocol. That's all it says. Baud rate setting function. Oh, hang on. Taking the baud rate 57 into blah as an example. Maybe the baud rate is not 9600 because on here, if I go to like in the manual, it's the example for changing the baud rate is changing the baud rate from 57600 to 115200. So I don't know, maybe I'll just try 57.6 as the baud rate. Disconnect, options, serial port, let's go to 57.6 and connect, and now do status. Nope, that didn't work either. Alright, now I'm going to look at the actual commands. So operation shift 0 to enter the setting mode of the baud rate. Alright, here we go. What's it telling me to do? It's saying press...
Scott Miller said turn it off and on again.
Yeah, maybe. Yeah, I wonder if it needs to detect the port at startup. Shift. Where's shift? Shift 0. Okay, so that's COM. And set BPS 1. 15.2. What? Rotate the knob or press the up buttons to adjust the displays. Oh, so if it's 152, it's in 100. It's already in 115,200 bits per second mode. Okay, escape. Let's try that. Maybe that is the answer. It could just be that it's already in 115,200 bits a second. So that one and connect. Let's try this. Nope. Nope. Alright, I'm going to change my line endings back to both. And connect again. Status. Status. Nothing. Okay. How about I change to... I am going to explicitly set the baud rate this time, so I'm going to go into... No, not 0. Escape. So I want shift 0 to go into comms mode.
Scott Miller said smack it.
Naughty load. Okay. Rotate the knob or press the up and down buttons.
45 minutes remaining.
So 57.6, 38.4. I'm going to set it right down to 9600 bits a second. Press enter to confirm. Enter. And it says please modify when there are no communications. Okay, whatever. Taken in 57.6. Alright, I'm just going to unplug USB. Where is that cable? There. That USB connector really didn't want to come out. Plug it back in. And back on here, I'm going to disconnect. Might have to... Is that port still there? Rescan. Yes, the port is there. Change it to 9600. 8N1. I don't have any flow control other than software. Line mode, blah. And connect. Connect. This is very sad. It would have been nice to see something. Ah, prefix with a colon. No, that doesn't seem to do it either. Okay, let's just push this off over there for a minute.
Tassie Bob said prefix with colon.
Yeah, I've just tried that and it didn't seem to do anything.
Mitchell R said try raw send ASCII, or see if something comes back.
Raw send ASCII. Let's see, how do I do that in here? Send string. Plain.
Scott Miller said reboot it with USB connected.
Yeah, that might be worth trying. Alright, Scott, I'm going to try that. So let's... Okay, that is on, off. Turn off power. Let it sit for a minute. Then we'll turn it back on with USB connected. And that's it. Actually, what I'm going to do is just check what the baud rate is set to, see if it is still on 9600. So I'm going to go into comms mode. Yep, 9600. Okay. Disconnect, options, serial port 9600. Port is still there. Looks fine. Connect. It could be that line ending still. So, carriage return versus line feed. So line feed is new line, I think, isn't it? It's just a different, sorry. Brain heading off somewhere else. Colon status. Colon status. Nope. Prefix with colon, suffix with question mark. Yeah. Yes, Kim, so I've tried that. That didn't seem to do it. It would be useful if whatever protocol this thing was talking, if it didn't understand a command, it would respond with a NAC or a an invalid message or something. That would be handy. Star IDN. Okay, let's try star IDN question mark. Yes. Okay. So that means that, so IDN, that is part of that standard protocol, isn't it?
It detected as a modem. Maybe it wants old-fashioned Hayes-type comms.
Oh, and Michael said, in theory, a line feed by itself just pushes you down a line, leaving you in the same cursor position. Yeah. So normally it's fine to send both a carriage return and a line feed. But anyway, so when we did the question, what was it? Star IDN question. It identified itself. Now what is that protocol? I've gone totally blank on it. There's like a standard instrumentation protocol that uses IDN. It's okay. IDN. No. It's used by multimeters and all sorts of things. Multimeters, IDN. Where is it? Stat. Okay, let's try colon stat. Yes. How about colon status? Doesn't do anything. Okay, so if it gets a command that it doesn't understand, it does not return anything. Okay. Now, we're getting somewhere. We're getting somewhere. All right, so what I'm going to do is turn the power supply back on So I've got it set to 12 volts, 1.5 amps. You can see, sorry, 12.3 volts. You can see we're getting it coming through here. And what have I got it set to? 0.1 amp. I'm just going to turn that up a bit. No, not the minimum thing. I'll turn it up to 0.5 of an amp and enter. Where's the enter button? There. All right, so we've got it set to that. We're going to turn it on. So now we have power going through it. Let's go back to the status. Do a stat again. Oh, that's sad. We're just getting all 0 values coming out of it. Skippy, yes, that's right. SCPI, thank you. So Skippy format. SCPI commands. Scott says front panel designed by Shotgun. Yep. VSet, ISet. Yeah, so Tassie Bob's got some suggestions here. So this is Skippy stuff. How do I send Skippy commands? All right, let's try Tassie Bob's thing. So was it with a, yeah, so it's with a colon to start with. So now we can do set, I'm going to do set 1 colon 0.6. Yeah, don't know. A bit of a guess. Power supply not allowed. Yeah. Steve Squirrel says, check the device manual. No, the device manual is useless. It says, and I quote, communication with PC, section 17 of the manual. This is the entire contents of the manual. Please refer to the communication protocol. Good one. Thanks, Tenma. That's very useful. I wonder if this has anything to do with it. When I buy things with a CD, I never even look at the CD these days. Ooh, TST bar for self-test. Oh, Jordan's here. Nice. Yeah, so this DC lab power supply. Hang on, it says lab power supply. This is the thing that came with the load, and it says software/driver. I don't even know if I have a way to read a CD. But that might be, I might have some clues. If I can figure out a way to get this into a computer. Do I have a computer anywhere with a CD driver? I'm not sure that I do. I have so many computers here and no CD drivers. Okay, so David T says status is just the baud rate, etc. All right, I've got a bunch of suggestions of things to try.
CD is only compatible with WinDRP 3.11.
Yep, so I need a WinDRP 3.11 computer. Status is just baud rate.
Try OUT1.
Yeah, okay, so I'm going to do colon out one question. Nope, that didn't do anything. I'm going to try car 2A without a space, and then I'm going to try car 2A with a space. No. Star TST question for a self-test was Stephen's suggestion. Nope. What about colon TST question? Nope. Colon TST. Nope. Oh, Tassie Bob said ISet? Is that ISet? I can't see what you've done there. ISet. Also, do I need the colon? I have a feeling that I do. So if I do colon status, nothing, colon stat question, it gives me a response, but if I do stat question without the colon, gives me nothing. Colon I set question gives nothing. Colon out 1, nothing. Yeah. I think... Ooh, Kevin Aussie had a suggestion. Oh, and Scott had another suggestion, which is just I question. No. So Kevin Aussie's suggestion was colon mes for measure colon all question, and some variants of that. So all colon DC. No. I suspect that digging into this may give some interesting clues. Ooh, in 1. Okay, let's try colon in 1. Nope. It'd be really nice if it responded to help or had some kind of documentation. Where is the protocol? So, Tenma tell you. How am I going to get this? How am I going to read this CD? I think I have an old laptop with an external eSATA DVD drive. Oh, Kim said mes car, so let's try that. Colon mes colon car. No, what about with a question mark? Oh, yes! Yes! Kim S.
Scott Miller said maybe the commands are actually in Chinese.
Yeah, Scott, maybe you're right. But check this out. Mes car worked. I'm going to start making some notes. Sub. All right. So colon status question worked. Mes car worked. All right, I've got to start keeping a record of this. There, that'll do. Which, of course, suggests mesh volt. Yes. Hang on, but why is that so low? Oh, it is that low. Oh, that is actually correct. Check this out, because I've got the load set to 2 amps. It's getting 1.498 amps because the limit on the supply is set to 1.5, and it really is only seeing 0.0814 volts. So if I decrease this load, so if I go to constant current, what am I wanting to change? Okay, if I just start dropping this load, 1.9, 1.7, I'm going to drop it down to 1 amp and
System notification.
enter and
30
turn it back on.
remaining.
Okay, so now we've got 1 amp set.
Tassie Bob said check that link above. We'll give you a text file with all sorts of nice stuff.
Ooh, Tassie.
Mitchell R said wait. Did you turn the input on?
Input on? I did just then, yeah. So now if I repeat that command, you can see that we've got 10.82 volts, and if we do the measure current, we're getting 0.9991 amps. Yeah, okay, so now we can do mes volt. Was it volt or volts? Volt, yep. Mes volt. So I wonder if we can do a set. Set. Come on, I can type. Set car 0.9. I've got no idea if that did anything. No, it did not. I'm just guessing here. Okay, now where was... Oh, volt V number to set. So Tassie Bob was just suggesting some things. Hang on, I've got to... There are lots and lots of suggestions in the chat. Say check the link above. We'll give you a text file with all sorts of nice stuff, says Tassie Bob. Okay, so where is Tassie Bob's link? Where is the link? I don't see a link. Tassie Bob. Maybe where I can't see a link. Mentions ASCII, so maybe there's a link to some Python code by the look of it. Denied due to previous smoke evacuation error. Yeah, I am way back. Oh, more docs. Okay. Let's see if this is... Yeah, maybe this is what Tassie Bob was referring to. This link that that Mitchell put in. Alright, so voltage, current, save, recall. Okay, so we've got some possible things here. Now, the other thing I'm going to do is take a record of this. So, Tenma DC load. Resources. And yeah, so I'm going to grab a quick record of this before I lose track of everything, because so often in these situations I come across useful stuff and then I can't remember where I found it later. Verified commands. And where are we? Here, okay. So, back to the bottom again. Those eyes. Fault 9VF, fault 9V, current 2A. Okay, so, oh, measure what? Okay, so that's a very good idea of something to try. Alright, I've just got to arrange things a little bit more sensibly here. So I need that there, and I want call term there. Now, view. Can I zoom on this? Nope. How to view...
Mitchell R said Tassie not mod, can't post links.
Ah, okay, that's what it is. Settings, let's... Nope. I just want to make this thing bigger to make it easier to read, because this is a pretty small terminal. Options. Terminal. Is there a font size? Fonts, there we go, fonts. Let's make this bigger. Color of Monaco. Font terminal. Font size input fields. Let's make that 18 point and see what happens. Yes, it got bigger. Okay, that's a little bit less horrible. In fact, I'm going to make it even bigger. Let's make it 24 point. Yeah, that's more like it. Comfort size. Now, where were those commands? So Crispian was suggesting to say mes what. How about mes watts? Nope, that doesn't work. Oh, that's a pity. Hang on, I got a cough. Ah, okay. Where were those commands? Okay, so Tassie Bob was suggesting to try car space. I'm going to try 0.4a. That worked. Wow, hang on. At least I think it did. I'm just going to try a different, there was no response, so we can't verify, but I'm just going to try setting it to 600 milliamps. It changed. You can't see that, but that actually changed. The annoying thing is that there is no acknowledgement from the unit to show, but what I can do now is if I do, say, measure current, look at this, 0.5988 amps. And now I will do set current to 0.3 amps, and then measure current again, and now it's 0.992 amps. Look at that. So we can do, make a note of this, car space 0.3 amps. Okay, just as an example. Cool. Which means we can probably do volt as well. So volt mode versus, we could do constant volt mode versus constant current mode. Yeah, right.
Mitchell has said try cur less than with a space.
Scott said mes smog. So David said there is a spreadsheet for the commands on the EEV blog link for Corad Kel 103. Corad Kel 103. Okay. Corad. Scrolling back in the chat, looking for the link. Corad. I should be able to do pow W watts. Okay. What I can't do yet is measure watts. Like if I do mes car, it'll show me current, but if I do mes watt, gives me nothing. Watts, maybe just an S. I mean, maybe just a W. Let's try that. Nope, that doesn't work either. Let's try, yeah, let's try pow. Pow, yes! Okay. Measurement setting. So I can do mes pow. Okay. We are getting somewhere. Yeah, I wonder if I can turn the output on and off. Because what would be useful would be to have it starting in an off situation and then turning the load on. But I wonder what happens if I do car 0 amps. What has it done now? It's gone to 0 amps, but the output is still on. It hasn't actually changed the output status. I need a way to be able to turn the output on and off. So if I do measure power now, it's going to say 0. But if I set current to, let's just put it to 800 milliamps and measure power, and now we've got 9 watts. All right, so as long as the output is turned on, we can set the load to 0, but we can't turn the load on and off. And that is important because if it starts up not turned on, we want to be able to turn the load on. Imp on, says Tassie Bob. All right, let's try that. Imp, I'm going to try imp off.
Scott Miller said it's a load.
That
Does
worked.
it really have an output?
Now if I do measure power, see it says 0, and now I'm going to do imp on, measure power, and it's back again. Yes. Imp off. How did I get a backslash then? Imp. I'm just going to do it as a separate line. Imp on. Okay. We've got. Now the thing is that with what we have here, this is actually everything that is needed to make this a useful programmable load to integrate with the test rig, because we can now set the load, like the current, we could set, and we can turn the input on and off, and we can measure the outputs. We can measure the readings. Yeah. Ooh, info question. Okay, let's do info. Info question. No. Nothing
Mitchell R.
useful
said
there.
Stat, not status, I think, for your notes.
Ah, yes. Thank you for picking that one up. You're absolutely correct. Status doesn't work. Stat does work. Peter asked, can you stack commands on a single line? I don't think so with Skippy, because the protocol specifies a new line for differentiating. But let's just try that. Okay, so the current status is, I'm going to set input to off. How am I going to show this on screen? All right, I'm going to do a measure current. All right, so current is currently set to 0.8. What I'm going to do is say input off, and then I'll do input, no I won't, I will do cur 0.3 amp space colon, I'm pretty sure this isn't going to work, and then imp on as one line. And then we're going to go back to measuring, and it's 0. Yeah, so it would have failed. It hasn't turned it on, and it hasn't changed the value, like the load setting. So neither of, if I do that combined, neither of these commands work. You have to do it as, so if I did current 0.3 and then I did imp on, and now we measure it, now we've got 0.3. That's not a problem. Oh, imp should tell you if it's on or off. Imp. Haha, yes it does. Imp. I'm just going to add some notes here. Returns on or off. Yep. I guess. So I'm just going to, I assume it says, so I'm going to say off, and then imp now says off. Perfect. Kim S asked, multiple commands on the same line. Can you add the \r character in the string being sent? Probably. Well, you could put in a new line character, but that's essentially the same thing. So what I'm doing here with
System notification. 15 minutes remaining.
Now the thing is that if all of this was being run out of an automated test jig, it doesn't matter. You don't need to stack commands because you can just send them sequentially. It's not a problem. So what you would do in your code is have it send the current like the current setting, or maybe turn off
Cassie Bob says
the load.
And POW for the power set point.
POW for power set point. POW question. Yeah. Oh, excuse me. Now, maybe we need to get the mode, because okay, I'll show you why in a moment. POW
Cassie
question.
Bob said volt and cur.
Yeah, volt and
Mitchell
cur.
R said basically A on any set should return its state.
Yeah, so put a question mark on anything, will return the state. So if we say colon car question mark, it says 0.3 because that's what the value is set to. If we say volt, it'll say 0.1 volt because it is set to 0.1 volts.
Cassie Bob
But
said those aren't measurements. They're
No.
showing you the set points.
yes, exactly, that's what I'm getting to. So this is showing the set points, but if I do mes volt, so 0.1 volts is the set point, 12.9297 is the actual measured voltage. But the thing is that what we don't know is what mode it's in. Is it in constant current mode, constant voltage mode, or whatever? And yeah, so we could be taking measurements here and it could be in constant voltage mode, not constant current mode. So ideally I need to figure out a way to read and set the mode. Tassie Bob set mode. Yeah, I tried that just a moment ago. It's in my history here somewhere. Yeah, colon mode question mark. Returns nothing. How about just mode? Returns nothing. How about mod? No. Func. Okay, so that's one I haven't tried before. Func question mark. Yes! Yes, Tassie, you got it. You got it. So, func returns CC, I guess constant voltage, probably CP for constant power, I don't know. So now if we put it, yeah, we could set it to constant voltage
Cassie
mode.
Bob said nah. Kim got that one.
Oh, Kim. Okay, so Tassie was, Kim had said the same thing. Cool. Func. Yes. Func. All right, so we would also be able to do colon func CC, for example, or colon func CV for constant voltage. All right, so what I'm going to try now, I haven't actually tried this at all in constant voltage mode. I've only had it in constant current mode. So here's the test. Without even looking at it. So this is the cool thing is I'm sitting here staring at my computer, looking at this serial console. I'm not even looking at the equipment. It's sitting on the bench behind me, not touching it, not touching it. And now we have full remote control over it. So what I'm going to do is go to volt, and I can see that it's set to 0.1 volt. I can do func, and I can see it's in constant current mode. We currently have 12.3-ish volts going into it. I am going to set the volt to 9.8 volts, just because. Okay, so now if I query volt again, it's now set to 9.8 volts. If I query func, it is still, it's switched to constant voltage mode. Interesting. So if you set any parameter, it goes into the matching mode. Right. If you set a parameter, I type good, amps, volts, etc. It goes into the matching mode. So
Mitchell R. said Tassie is on a roll today.
yeah, thanks Tassie. So volt 9.8V will change to constant voltage mode and set it to 9.8V. Right. So we currently have, if I do volt it is set to 9.8. If I do current, it is set to 0.3 amps. If I measure current, it is 0. Oh, because it turned
Scott Miller said John hasn't even seen all the SIST stuff.
it yeah, it turns off the output. So now I need to do imp on. Now this may make it go, let the smoke out, let's see. Nothing bad happened. So now if I do measure current, I can see it's pulling 1.48. Yes, 1.48.
Scott Miller said cause he's ignoring chat again.
Yeah, I'm ignoring chat. It's because I'm I'm getting excited about this. Experimenting. All right, so it's in funk. So it's in constant voltage mode. It is set to 9.8 volts. Measure volt. It doesn't seem to be actually... Oh, okay.
Outside the box said lol.
Here we go. 9.7976 volts. And it all seems good. So now if I... Alright, just as an experiment, let's see what happens. It's currently on. It's in constant voltage mode. And the current is nearly 1.5 amps. So if I do something like, let's just do, not pun, it'd be funny if there was a pun mode. Imp is on. Okay, now I am going to change the setting on the constant current mode. I'm going to do car 0.42 amps. So what this should do, based on my understanding so far, is turn off the load and change the setting of the current value and put it into constant current mode. So let's see if that's what happens. So 0.4, I've sent the command. Now if I'm going to check the input, it is now off. If I check the, current's going to have 0. If I check the current setting, it is 0.42. So now if I do imp on, it'll now have turned on the thing. So if I do a measure on current, we're now pulling 0.418, so it's turned the output on. And if I do a func query, it's in constant current mode. Yes. Okay. Very good. Very, very good. This is nice. All right. Kim asked, just curious, can you do something like measure volt current? I don't think so, because the value that comes back is not going to make much sense. So that would be mes
System
colon
notification.
volt
5 minutes remaining.
colon car. Yeah, it doesn't do anything. Because keep in mind that you need to be able to parse the results that come back from this. So that's one of the arguments against stacking commands. If you send two commands that both return values, how do you know what the response refers to? All right, so let's go back to the system stuff. You can do colon func with CV. Yes, yes. That's in my notes down here. CWCR. So that could be. Let's actually do this properly. So func CV, CW for power, and constant resistance. All right. There we go. We've got all four options documented there. And let's do this as well. So now we've got the documented input on off and function set. Yeah, in this sort of situation, I mean, this is the definitive way of specifying this is the command and these are all of the options you can send it. I actually, in this sort of documentation, when I'm just keeping notes for myself, what I really like to be able to do is just put actual literal commands as an example. Maybe, how should the syntax be done here? I could just do this, :func cc. Yeah, no, that seems messy. Anyway, this is just notes for myself at the moment, so that'll do. Now, back to syst. Alright, so what is all of this syst stuff that people are talking about? Factory reset. Okay, so we've got syst factory reset. What other syst things can we do? Scott says, when he finally looks at chat and discovers he could be using SSH or Telnet instead of CoolTerm. Telnet? Telnet? Seriously? Alright, so syst port. Okay,
Scott
syst
Miller said
DHCP.
networking.
Networking, yes. Alright, so let's do syst.
Outside the box said, welcome to Jana's Black Box Interrogation Reverse Engineering class.
Look at that. Yeah. To get the system address. Measurement. Let's see. Configuration. I don't know, I'm just making up headings here. Alright, I've got to get myself an Ethernet cable. Returns IP address. Now, where's an Ethernet cable? There should be one. There is one. There is one lying right here. Is the camera still working? Yes, it is. Ugh. Okay, Ethernet. Let's see. I'm going to plug that in. Oh, come on. Oh, connector's upside down. That's weird. It's got the latch on the bottom. All right. Ethernet is plugged in. Let's come back to... I'm just checking whether anything changed on the display. No, it didn't. Okay, I'm going to do... Hang on, how did it... I don't know. 198. Is that actually its address? Let's find out.
System notification. Stream is over.
There may have already been a device on that IP before.
Miller said latch on top is upside down. Supposed to be on bottom.
Okay, supposed to be on the bottom so that things
Tassie
can't
Bob
fall
said
on
turn
it.
on DHCP, slightly smiling face.
Yes, okay. Here we go. So, what we want is syst DHCP, I think. Is that the command? Yeah, so this has got a, looks like it's got a statically set address at the moment, which funnily enough it matches my subnet. Alright, so syst DHCP, I just turned on. Now I'm going to do an IP address check again. Okay. Now I'm just going to try SSHing to that address. 68.1.198. Connection refused. Can I telnet to that
Mitchell
address?
said Kes for DHCP get.
Telnet, command not found. Sorry, where were we here? Turn on DHCP. Say quest for DHCP get. Oh, assist DHCP 1 or something, or on. Okay. Let's try assist DHCP on. I'm going to try this. Oh, it's currently set to 0. Okay, so 1. And now, still set to 0. sysdhcp. Oh, I'm just going to do the query again. Yes. Well, it looked like one of those commands worked. I don't know which one, because it's now got an address that is different. So it looks like it's picked up the address from, yeah, it's changed basically. So DHCP, so either DHCP on or DHCP, I'm going to try this and just see what happens. DHCP off, and then IP add still on that, and I'm going to do DHCP 0, and it's still on that. So once it's been assigned the address, maybe it doesn't give it up.
Said telnet on port 18,190.
Aha, except that I don't have a telnet client.
Cassie Bob said telnet on port 18190.
All right, I'm going to take a quick system config, sysdhcp. Just going to take some notes about this first. Not sure if this means anything, because it just returns 0. If I do sysdhcp question, oh, could just do this, it just returns 0. So now if I do DHCP on, it, hang on, no, I'm trying to get to, yeah, DHCP question. It still says
Scott
0.
Miller said, wonder if it is called home yet.
If it's called home, yeah. I don't have Wireshark or anything running to be paying attention. So if I do DHCP 1 and then DHCP query, it's still saying 0. So I don't know what is, it looks like one of them worked, but I don't know which one. DHCP 1 or on. Maybe one of these worked. Yeah, okay. So what I'm going to do is SSH to KO1. Come on, okay. KO1. Oh, I know why. I'm trying to SSH as the wrong user. KO1. That's better.
System notification. Peter is hangry. 5 minutes ago.
All right. So,
Mitchell R said might not be enable or disable for DHCP, but get DHCP if request, i.e. statement action.
Telnet 68.1.228, I think that was it. Connection refused. Let's try.
Scott Miller said Peter can starve.
Connection refused. Just want to check that IP address again. Yeah, 192.168.1.228. Check the port setting. It might not be Telnet, but TCP or UDP server. But get DHCP IP request. Statement action. Say might not.
Tassie Bob said try port 18,190.
Oh.
David T suggests it might be UDP disappointed.
Yes. Yes. What is... And telnet. What is the port? Where I can't even remember. Host port. Okay, that's all it is. So if we do telnet blah 18910, was that the port? 18190. 18190. Connection refused. 18190. Connection to food refused. Yeah, I need a connection to connection. I need a connection to food pretty soon, actually. So you do syst port. Oh, okay.
Tassie Bob said do. SYST port.
Syst port question. Yeah, okay. I wonder if that is a an SSH port. Oh, port. What's the argument? Port, is it just minus P? Port minus D. Oh, it's colon, of course. So if we did hooray for consistent syntax. Nope, not that. Yeah, I thought SSH was like minus P something. Like minus P 18190. Port 18190. Yeah, okay. That's not it. Okay, so it might be UDP or something. Nmap it. Yeah, it was
Tassie
the
Bob
correct port.
said Andrew Gordon.
Most likely UDP. SSH is minus P. Yep.
Mitchell R said most likely UDP server.
Yeah. Okay. A TCP or UDP server. Yeah. Alright. So that would take significantly more investigation. So, in my notes, I'm going to keep track of that. I'm going to say... I'll put it up here. Network port is 18190, but doesn't respond.
Tassie Bob said at Andrew Gordon.
Yeah. To say help. Most likely not going to use SSH, yeah. Alright, so most likely it is UDP. So, well, that is still very, very useful. I'm really impressed that this has worked and that it's like standard Skippy commands. This, with what this is right here, over a USB connection, that gives me everything that I need. It's yeah. Okay, best thing to check with EV blog forum for Cored Cal 103. Tenma is just an element 14 rebrand of the same thing. Ooh. Okay.
David T says best thing is to check Eve blog forum for Corad Kel 103. Tenma is just an element 14 rebrand of the same thing.
Yeah.
The forum has lots of info.
Corad KEL 103. Yep. Groovalicious. Yeah. So, where are we? Why didn't Crispian's message get said? Maybe it just hasn't got to it yet. I don't know. Oh, some call it fun. Pointed out, Wikipedia says that you can stack commands using the semicolon. Right. Okay. Yeah, I don't think I actually really... I can't think of a situation where I care about this, because if I'm just using this in a test rig sort of situation, I just want to be able to set it into a basic mode, probably leave it running in that mode for a little bit, read some values over time, and then turn it back off again. So yeah, what we've got here is 100% useful to me. Oh, Tassie Bob says, does indeed seem to be UDP. Okay. Well, that is what it is. The thing is that I can plug this in by USB into the Raspberry Pi that's running the test rig anyway, and then the test program can just set the dummy load into whatever mode it wants. So overall, this has been a huge win. I'm very happy with this. Now, options, what did I... 9600. Okay, yeah. So I changed the baud rate to 9600, but...
Scott Miller said 100% usable doesn't mean 100% perfect.
No, it's not 100% perfect. But it gives me the basics of what I need. Yes. Yeah, this is cool. I am quite happy with this dummy load. Now, I definitely need to arrange some foods. Yeah, I don't know why Crispian's message about finding a pizza shop wasn't said. What am I going to do for lunch? I don't know. I don't know. I have a few options. Funny thing is, right before the stream started, I grabbed a Tim Tam. It has been sitting here next to my keyboard since before the stream, and I have been resisting eating that Tim Tam.
Scott Miller said, if it's this smart, why are we still calling it a DUMMY load?
I don't know. It's not a dummy load.
Mitchell said he tried to say she that should not be named, so it's blocked lol, and he got banned for 15 minutes on the tree lol.
Oh, okay. That's what's going on. Yes. Yeah, so there is the auto ban on use of the forbidden word. Yeah, cool. All right. I'm gonna go, but this is cool. You can see it's still running. I can feel it's just getting slightly warm. The fan in the back hasn't turned on because we haven't been pulling enough power out of it to make it be really working. I'll turn it off and you can see that the current drops to 0. Measured voltage on the input is still there. Turn it on. We're pulling 0.42 amps, reading 0.418. This is a win.
System notification.
I like it.
Peter is super hangry. 15 minutes ago.
Yeah, and I'm getting super hangry too, so it is time to go. And yeah, in a little bit I'm going to go over to Jenny and Peter's place to see them, and yes, make me a sandwich, says Mitchell.
This is an order. Alexa, make me a sandwich.
Mitchell, you've made yourself a workaround for it. So exclamation order is a way of sending a voice command. Oh, all right. Seriously, I'm going to go. This has been interesting. I like it when things work out like this. And thank you very much to everybody that has helped figure this out. All those people busily Googling Skippy commands and figuring out syntaxes and things while I was just inputting it, and then I just get the benefit of everybody else's research and knowledge. That's yeah, as I always say, I'm lazy, and it's because I can get people like you to do all my work for me. But what I'm going to do is these notes I'm going to save. I'll put them somewhere. I don't know quite what to do with them yet, but it might be useful to put this information somewhere public, because it might be of value to other people as well. Save them. It's the sort of thing that would have gone in a blog post years ago, but blogs kind of don't really exist anymore. So anyway, I'll find somewhere to put it. So, yes, sorry, my brain was just off in the saying happy birthday to Nick and Chris mode. So, happy birthday, Nick and Chris, wherever you are. And thank you everybody for coming. I hope you have a fantastic weekend and coming week. That's a sign that I've been here too long. And I will talk to you all later. Thank you. See ya.